Hi precalc, and welcome to your second part of trig. This one here is sum and difference formulas. Again, this is on that sheet that you can use, so you don't have to memorize it, but you do have to know how to use them. So let's go. I hope you did well in the last one. Here we go. Okay, so the sum and difference identities. We're going to start with the difference identities. That just means you're taking an angle minus an angle. So when you're giving your homework or your quizzes or your tests, make sure you look at what they ask. Because sometimes angles can be done by the difference or the addition, the sum one. So make sure you follow directions so you get your credit. All right, so when you do this here, this is your formula. You take the sine of the first angle times the cosine of the second angle minus the cosine of the first times the sine of the second. It's just your identity. Cosine goes cosine times cosine plus the sine times the sine. Tangent is the tangent of the first minus the tangent of the second, all over 1 plus tangent of the first times tangent of the second angle. Let us show you how this works. I would like to find the exact value of the cosine of 15. Now, we do not know the cosine of 15. It's not one that we have. So I'm going to figure it out, and I know you can use your calculator to check, but you must show me all the work. So we're going to do, how do I get to 15? And there's lots of ways to get to 15, right? I can take 45 minus 30. I can take 60 minus 45. So your method and my method could definitely be different. All right, that is not an issue. Just make sure that at the end we're in the same spot. Okay, so for this one, I chose the 60 and the 45 just because I figured most of you would choose the 45 and the 30, just so you start to think a little differently. Cosine means I am using the cosine difference formula. So now the 60 minus the 45 has to equal the 15 because that's what I'm trying to find. So how do I get to 15? It's 60 minus 45. I hope you're good there. Now we follow our formula. So cosine of the first times the cosine of the second plus sine of the first, sine of the second. Now we know the cosine of 60 is 1/2. Cosine of 45 is square root of 2 over 2 plus sine of 60 square root of 3 over 2, sine of 45 square root of 2 over 2. Then it's just multiplication. 1 square root of 2, square root of 2 over 4, square root of 3 times 2, square root of 6 over 4. You can leave common denominator and done. This is good here. I don't need you to go any further. All right, I would like you to use two angles different than 60 and, well, actually, I don't think I really care. Okay, pause and try yours. Okay, I'm going to use two different angles that are different. You could have used the same ones above, but I just wanted to show you. So this is 45 minus 30, because 45 minus 30 is our 15, which is the angle we need to find. Okay, now we're using our angle difference formula on the top here. So we know that is the sine of the first times the cosine of the second minus the cosine of the first, the 45, times the sine of the second. All right, now we just type those in. Sine is 45. You should have these down now. Square root of 2 over 2. Cosine is 60, or 30. Square root of 3 over 2. Minus cosine of 45. Square root of 2 over 2. Sine of 30, 1/2. Multiplication. Square root of 6 over 4. Minus square root of 2 over 4. Even if you used different angles, you would have still got to this exact same answer. All right? I hope you did a good job. Those are quite fun. Next on the list, I want you to go backwards. So if I'm giving you the cosine of 80 and the cosine of 20. All right, so we know we are in our cosine law, right? Because the cosine is cosine, cosine. So the first thing I'm going to write down is this is a cosine. All right, I know that it's cosine, cosine plus the sine means I'm going to take 80 minus 20 to get to my angle. So 80 minus 20 is 60. So this is truly the cosine of 60. Well, I know the cosine of 60 is 1/2, and we are done. Okay, working backwards. You got sine, cosine, so we know this is the sine rule. I know I have to take 135 minus 90. So when you take 135 minus 90, you get a 45 degree. So this is sine of 45. And we know that is the square root of 2 over 2. All right, I hope you did a good job on that. Nothing too awful major. Okay, that was the difference. Now we're going to do addition. Works very similarly, except now your things are a little different here. We do sine cosine, but this time it is plus. And cosine is cosine cosine, but this time it is subtraction in the middle. The same with your tan. Your signs have changed. All right, we did sine and cosine last time, so I decided to do a tangent this time. I want to find the exact value of 105. That means whatever I add up, it has to add up to 105, and it has to be angles that we know. So your 30, 60, 90s, your 45s, those type. I know that 105 is 60 plus 45. Again, you can use different numbers. Now we just plug it into our formula up here. So tan of 60 plus the tan of 45, all over 1 minus tan of 60, tan of 45. All right, now we just plug in the answers that we know. We know the tan of 60 square root of 3, tan of 45 is 1. 1 minus tan of 60 again, square root of 3 times 1. So it's really the square root of 3 plus 1 over 1 minus the square root of 3. I am actually okay here if you do not rationalize that denominator. If you want to, you multiply by the conjugate, and that will clear that denominator. So that's 1, and that's 3. Distribute across the top, you have the square root of 3. You have 3, you have 1, another square root of 3. All right, so it's totally up to you if you want to do that or not. You're good. Okay, exact value of 255. All right, let's see if we can figure this out. Okay, what adds to 255 in sine? Well, when I look at this, I always like to start with the 45s because that gets that down to zeros. So that gives me 45 plus 210. All right, do I know those two angles? The answer is yes. So I'm going to do the sine, and I'm going to start with a larger one just because I like to, plus 45. Okay, and you're going to do, whoops, try to write an S and I wrote a 2. What's going on here? The sine of 210 times the cosine of 45 plus the cosine of 210 times the sine of 45. Okay, I hope you did a good job here. Now, we have to know what those are. Okay, sine of 210, well, that's negative 1/2. 45 is the square root of 2 over 2, plus the cosine of 210, that's a negative square root of 3 over 2, cosine of 45, square root of 2 over 2. All right, we should know those, correct? So this is negative square root of 2 over 4, plus negative square root of 6 over 4, which translates into negative square root of 2 minus the square root of 6 all over 4. Okay, I hope you did great. Last but not least is verifying identities. I want to prove that this equals this. All right, this one's a little bit trickier, so if you needed to work both sides, I probably went through with it. Okay, cosine of an angle minus an angle. So we're on our difference formula, right? Cosine of A, cosine of B, our beta, plus the sine of alpha, sine of beta, all over cosine alpha, cosine beta. All right, I'm going to break these up into two separate fractions. So cosine alpha, cosine beta over cosine alpha, cosine beta, plus sine alpha, sine beta over cosine alpha, cosine beta. Well, this is 1, and this is really the sine over the cosine. So sine over cosine is tan of alpha, sine over cosine is tan of beta. Not near as hard as it looked, was it? All right, now it is your turn. You have to prove to me that the tan of x plus pi equals the tan of x. All right, pause. Remember, you're using your addition identity or your sum. So you should have started off with the tan of x plus the tan of pi all over 1 minus tan x times tan pi. All right, we know that the tan of 1 or the tan of pi is 0. So this is the tan of x plus 0 if you wanted, all over 1 minus, well, this is the tan of x times 0. So these guys cancel out, and we are literally left with the tan of x over 1, which is just the tangent of x. We've done an awesome job, haven't we? All right, it is homework time. Make sure you post questions on the discussion board, and good luck.